Hello, my name is Paul Connett. You know, when some people look into a garbage bag, they see paper, plastics, glass, newspapers, metal, rotting food, and so on. What I see is the whole world being thrown away. In this videotape, we're going to be looking at waste management as if the future mattered.
And if the future mattered, we wouldn't be talking about waste management. We would be talking about resource management, because nature doesn't make waste at all. Otherwise, we'd be knee-deep in giraffe manure by now. One organism's waste becomes another organism's nutrients. And that's how the planet went on for millions of years before we came along. We came along and invented trash, and it's invented and made in two places. Our manufacturers make it by overusing and misusing, grossly misusing many materials, particularly plastics. And we make it, each one of us, every day by the simple act of mixing everything together. And when you mix the smelly with the non-smelly, the toxic with the non-toxic, and the useless with the useful, we shouldn't be surprised if we find the product is smelly, toxic, and useless. And also, in the process, we create an attitude towards this material, which is revealed by the language that we use to describe it. It is waste, it is refuse, it is garbage, it is trash. We pay good money for this in the morning, but by nighttime we hate it. And we hate the politicians that don't take it away. Take it away from our lives. Our responsibility is just curling that little bit of metal around the plastic bag and putting it out, so we are told. We are told that the American public has in fact struggled for 300 years to hang on to this sacred freedom of putting all our trash into one plastic bag, which is taken away. But as Barry Commoner has pointed out and others have pointed out, there is no away, and now the evidence is piling up that we have a problem, and it's called a landfill crisis. If you keep throwing these things away, eventually someone's going to find where you put them, and where you put them was a landfill. So we have a landfill crisis, and I think it's important to analyze what that crisis is. We have too much material going into landfills. We have a space problem. We run out of places to put all this stuff. There's too much toxic material going into landfills, which gives us a leachate problem. And we have too much organic material like food waste and yard waste, which breaks down under the ground in landfills by the wrong set of microorganisms. Two sets of microorganisms. One set loves oxygen, and the other set hates oxygen. We turn on the wrong set in landfills. We turn on the microorganisms which hate air, and they produce some of the smelliest compounds known to man. The food, etc., attracts vermin. It's sad to call seagulls vermin, but when you've got several thousand of them in a field near you, they're not so attractive. And also we produce methane gas, which can explode. And most importantly of all, when this biological material breaks down, it produces organic acids, vinegar excelsis. And that vinegar, etc., dissolves the other toxics in our waste stream, the metals in batteries and so on, and takes that into our groundwater. And that's compounds then the leachate problem. And then we have too much useful material going into landfills. And I think we have an ethical problem. I mean, when you consider that we have consumed more of our finite resources since World War II than the whole of humanity consumed before World War II, we have an ethical problem. We're in fact a war on the future. We are robbing our grandchildren of these resources. If it was for essential reasons, maybe you could defend it. But considering it for often, we are robbing them for very flippant reasons, which we will discuss later. Throw away razors and throw away flashlights and throw away this and throw away that. That's not a reason to rob the future. People who don't like living near landfills, we have a political problem. The political problem, maybe the space problem that we referred to, and number 5 are in fact the same thing. We have in fact a lot of space in the United States, but we have a political problem using that space for landfills because of people not wishing to live near these things. And politicians know and knew in the 70s and the 80s that if they tried to cite a landfill in somebody's community, in their community, they wouldn't get voted in at the next election. So they were desperately looking for a way to avoid landfills. We have some agreement. I think everybody agrees that we have to reduce the quantity, the toxicity, the organic content, and the usefulness of the discarded material going to landfills. You've never seen a landfill, they look something like that. And there the agreement ends. Okay, we want to reduce the quantity, the toxicity, the organic content that goes into landfill. And there the agreement ends, because there really are two approaches which are diametrically opposed. The first approach is what I call the Rambo approach. You don't like something, destroy it. Get out your flamethrower and zap it. You don't like waste, let's get rid of it once and for all. Put it into this huge furnace. That's called destroying your resources. Secondly, the second approach is to recover your materials. Our task is not to find a new place to put the trash. Our task is to unmake the trash, not to allow ourselves to make waste. We make waste by mixing. If you separate your discarded materials, then you are in the genuine business of recovering them, and we can recover objects. We can reuse objects, which is the best way of recycling, is to reuse the whole object. The next best way is to recover the materials, and the many materials that we can recover. After that, we can compost the organics, the food waste and yard waste. We can make a special effort to get the toxics out. We can have some selective burial, which does not involve the complicated and expensive new breed of landfills, because we know it's non-toxic, it's not going to go anywhere. And we can have also some selective energy recovery at the very end, recognizing that always energy recovery is a failure to recover materials. If you fail to recover the materials, then you start to consider recovering the energy. In that respect, I would say the most promising form of energy recovery from waste will be the conversion of cellulose. After you've recycled paper as many times as you can, then you convert the cellulose into alcohol, a fuel which is extremely clean to burn, which would therefore kill two birds with one stone. And needless to say, we are going to get a landfill at the end of that strategy, because there will always be some residue. However successful your recycling program, there's always going to be some rejects, and those rejects will have to go to a landfill. It seems to me that one of the critical questions that we have to address in waste management is how we design a landfill which is politically acceptable. Clearly, a raw waste landfill is politically unacceptable. I think from what you'll hear in a moment, an ash landfill is unacceptable. I think that one of our problems is the traditional approach by our regulatory agencies to making a landfill politically acceptable to the people that have to live near them, is to persuade them that their design won't let anything out. And I don't think anybody believes anymore that nothing is going to come out. The EPA certainly doesn't believe that, and most citizens do not believe that those layers of plastic, layers of clay, the capping arrangement, the collection systems, and so on, are going to work forever, or even a short time, even their own lifetimes. So it seems to me that that policy is bankrupt, trying to persuade people you can control what comes out. More likely to succeed is to control what goes in. And that is the real advantage of this strategy of source separation, is that you have your best shot of controlling what goes into a landfill. And in particular, we can make a special effort to keep the toxics out of the landfill. That is a huge step forward. And by doing the composting, we can keep the organics out of the landfill, which, as you saw earlier, makes a huge difference in terms of what happens when you put that stuff into a landfill. At this point, I would like to go back to incineration, discuss the ash issue. Is the ash hazardous? Well, there are 4 classifications of being hazardous according to the EPA. Are they corrosive, explosive, flammable, or toxic materials? And as far as the toxic classification, this applies incidentally if you're a small generator, a small business, you're producing over a certain quantity of solid waste, then the question is asked, is your waste material toxic or not? Now, as far as the fly ash results are concerned, these are test results which have been collated by the Environmental Defense Fund And I've underlined in red if it fails for lead, and I've underlined in green if it fails for cadmium from fly ash around the country. And you can see that, in fact, 100% of the fly ash is, in fact, failing the EP toxicity test for either cadmium, lead, and usually both, by very wide margins. It always amazes me that the incinerator industry wants to pretend that this ash is not toxic, because if you tell me that the ash is not toxic from an incinerator, I'll tell you that you've got a lousy incinerator. Because the better you get with your air pollution control devices, the more toxic your ash is going to become. The lead and cadmium are indestructible. So to try to maintain that your ash is non-toxic is to really to say that your incinerator technology is inadequate. Now, an interesting thing happened with the EPA, which, like many regulatory agencies, thought that incinerators were the answer. Back in the early 80s, they said, well, the fly ash usually fails, the bottom ash usually passes, therefore, what you should do is to mix the fly ash and the bottom ash before you do your test. If you do it outside the plant, that's illegal because that's called treating hazardous waste. But if you do it inside and pretend that that's your product, combined ash, then that is legal, even though the fly ash is produced over here and the bottom ash is produced over there. But unfortunately for the industry, that is not working either. In fact, it turns out that 47% of the combined ash is now failing the EP toxicity test. Here we go, 100% for fly ash, 38% for bottom ash, and combined ash, 47%. It doesn't make either economic or environmental sense to convert 3 tons of trash into 1 ton of hazardous material. Because if you had trouble finding a place for trash, you're going to find an even greater problem getting rid of hazardous material. There's far less facilities available and permitted to accept hazardous waste. Let me tell you what's happening to the company that's building the Hennepin County incinerator, Blount Corporation. Now, Blount has built an incinerator in Warren County, New Jersey. They have these 3 major problems. First of all, the ash is failing the EP toxicity test 45% of the time. New Jersey law requires that that be sent to a hazardous waste facility. It costs them $250 a ton to send it each time it fails, $250 a ton. Their tipping fee for the plant is $98 a ton, so you can see what that does to the economics of this whole operation. If you're taking in $98 a ton for 3 tons coming in, and when it fails you have to pay $250 a ton, that makes a mess of your economics. Also, the tipping fee of $98 a ton also makes a mincemeat of the delivery of trash to your plant, because the haulers in New Jersey, in the county, find it cheaper to take the trash to Pennsylvania, where the tipping fee is much less. So the result is that the incinerator has received far less trash than they anticipated. The result is that Blount has just taken the county to court and sued them for $1.8 million to make up for the shortfall in delivery of the trash which they were committed to deliver to the incinerator. That's $1.8 million. The thing hasn't been running for more than half a year, I think, certainly not a year. And the other thing that's happened is something else that we predicted, that they forbade the recycling of newspapers because they need the newspaper for fuel in this incinerator. So now we see integrated waste management in full flight. You will not allow the recycling to take place at the maximum. You have to maximize your running of your incinerator to pay back the enormous amount of money that you borrowed to build this thing. You are not going to maximize your recycling program. If you believe in integrated waste management, then you're rather akin to somebody who believes that if you put a tiger and a lamb in bed together and leave them alone for a little while, you'll be given tiglets. As you know, the tiger devours the lamb, just as the incinerator in which you've invested so much political clout and so much money is the thing which is going to be fed first, not your puny little recycling program, which has got a fraction of your resources and a fraction of your commitment. Well, at this point, we're going to move over to the moving pictures, and I want to show you what ash really looks like. This modern state-of-the-art incinerator, which was Connecticut Showcase, can't burn newspaper very well. In fact, every incinerator that I've looked at, whether it was in Canada, Germany, Sweden, or the United States, every single one that I've looked at, you can pull out newspaper from the bottom ash. You can sit down and read the newspaper. I've also pulled out lottery tickets. You can read those too. Here is a newspaper in West Germany. This is an incinerator, modern incinerator in West Germany. And we're also going to see some other items now, which I pulled out of the bottom ash. This is a hot pepper. It may have been hot, but it wasn't burnt or cooked. This is a lump of bell pepper. And it makes you wonder if these incinerators have a hard job destroying vegetables and newspaper about these very highly controlled technology that we're dealing with. That's a lump of orange peel. And coming up is the stalk of a banana. And now, this is in that same incinerator, this is the modern air pollution control equipment. This is the lime scrubber and a baghouse, the flax system out of Sweden. Excellent results for removing metals and dioxins. And what you're looking at here is the difference between theory and practice. Because having removed that cadmium and that lead, look at the way they are collecting it. So now, I was breathing that and is going into the environment, you name it. So even when you've got the equipment, you're still subject to human error.
These are pictures that I shot of the ash landfill, which is directly behind our house. In the center of the picture is my husband standing. He stands 6 foot 2 inches tall, so you can kind of get a basic of how tall he is compared to the actual landfill. In the foreground of that picture also, where you see some sand and there's a small wall it looks like he's standing on, that was a future cell. It was constructed last year. This is now November 30th, 1985, and that cell is totally filled, and they are filling another one.
I'm talking with Bruce Grover here. This is the husband of Persis. And we're standing near the leachate pond from the ash landfill, which is just 1,300 feet from your house.
Yes, it is.
And I noticed that this leachate pond is pretty close to the top, right?
Yes, it is. It's probably, I would say, within 2 feet of going over. This is where usually we find it.
Right, so if we have a lot of rain, if we have a big rainstorm, it will overflow in one day.
Oh. And what happens to the water once it's overflown?
Then it drains down into a natural pond. And for 3 years, it's been 3 years since anyone has even tried to fish out of that pond because there's no fish left. Then the pond drains into a stream called Moose Brook, and Moose Brook then leads into Royal River, which then goes into the Kennebec and then onto the ocean.
Again, this is the ash now from the Auburn, Maine plant, and again, as you look at the ash, you wonder what all this burning was supposed to be about, because you can pull out plastic objects, paper objects, you name it, plus, of course, what you would expect, the metal objects, but it doesn't look so very different from raw trash in many respects. Certainly not quite what you imagine ash would look like. That's Auburn, Maine, built in the 80s. Now, this is West Canterbury, Connecticut. This is taking the ash. We followed the ash truck from the Wyndham plant, and sure enough, it was ash that was being tipped out here. And what was interesting about here was that this ash was being mixed with regular trash. In fact, it would have appeared that the ash was being used for landfill cover. So whilst they talk about monofills, you should be aware that most of the current practices, if they can get away with it, is to dump the ash into regular landfills. The very landfills that they condemned in order to build the incinerator in the first place. Ash, this is partly ash here, which is being used for cover. This is one of the highly touted, most modern incinerators fitted with best available control technology in Marion County, Oregon. This is an Ogden Martin facility. Here's the screening process. This is where they pull out the household toxics, like the mercury batteries in your watches are very correct. This is the ash dropping 30 feet, not exactly the way to minimize the dust in the plant and the impact on the workers. This is now a monofill. You're looking at a monofill here in Oregon. This is the wood, the 10 miles away from that Marion County facility. In winter, it looks fairly benign with the snow sitting on it. But in summer, when I went there, it was all dried out, and you can see that the ash is blowing from the surface, that fine ash, and it isn't being covered on a daily basis. Just last week or a week before, 100 people went to a meeting to complain about this ash pile, which is now 100 feet high. This is another state-of-the-art monofill, which won an award for the designer, Malcolm Perney. And this thing, which looks like a puddle, is in fact a lake. This is the water sitting on top of that ash landfill. It looks like a lake, but believe me, that is a monofill for ash. And when that this water was tested, it was 50,000 times higher than the safe drinking water standard for lead. That result we had to get from a legislator from the county next door, and in a moment you're going to witness something quite extraordinary in the annals of ash landfilling. There's a 30 milliliter plastic liner under here. This is on a hill. Oh, this is interesting. See these bubbles here? This is almost certainly methane gas coming out. And one wonders how you can get methane gas from an ash monofill.
This is an oil filter, which there's another one over there. And here's wood that isn't hardly even burned. Not even burning. I don't even know if there's any date or anything on this. I can't read any date on it. But here together with fresh newspaper.
This is the monofill, state-of-the-art monofill being used by local children on three-wheeler vehicles. And you notice that the dust it's a fun place. It's like a motorcycle track. Here they're washing the wheels in the liquid here. And that stuff's pretty deadly. Now I want to show you some other, talking about special treatment for ash. This is where the ash from the Washington, D.C. incinerator goes to the grounds of a mental hospital in Washington, D.C. This is the St. Elizabeth's Mental Hospital. They're using the ash there for landscaping purposes. That's what they're doing right now. Over in Saugus, Massachusetts, they're putting 300 tons a day, every day for the last 13 years. You multiply that, 13 years times 365 times 300 tons a day of the ash has gone into the adjacent salt marshes with no liners, no cover, no leachate collection, nothing. But according to the Massachusetts DEQE, that's all right because they're not actually disposing the ash there. They're simply storing it there until they find a better place to put it. This is Glen Cove, New York, another incinerator with won a state-of-the-art design award, and there's the ash being stored on the parking lot. And when I was there, it was raining, and the leachate, the black leachate, was going down the storm drains straight into the Glen Cove harbor. They wanted to use that ash for the base of a racetrack in Long Island. This is the ash from the Philadelphia incinerator.
Two years ago, concern over ash safety left the city with nowhere to dump the mountain of ash produced by its two incinerators. So Philadelphia got creative. It loaded 15,000 tons of ash onto a ship and sent it south, hoping that what the first world wouldn't take, the third world might. But 5 countries have all said the ash is too dangerous. In Haiti, the ship's crew tried to convince people the ash was construction material. They even ate some to prove its safety.
That's how worried I am of the toxicity.
Still, the Haitian government ordered the ship to take its ash and leave. If it sounds familiar, it should. Last year, New York's garbage barge drifted for 5 months before finally returning home. The ash ship has been at sea now for almost a year and a half. It'll return to Philadelphia this week, where the ash will finally be buried.
That ship of ash, I think, symbolizes the fact that incineration does not provide a total solution to the trash problem. Nobody wants that ash in their backyard any more than they want the trash.
I find, both with hazardous waste and trash incinerators, the most definite thing that you can say is there's a world of difference between theory and practice. And that difference between theory and practice is damaging people's health and it's damaging our environment. In Detroit, this modern incinerator, no stone was going to be unturned not to protect the people of Detroit. 3,300 tons a day, the biggest in the world, actually built without the best available control technology. I was called in by Greenpeace to look at the results from the ash. They had analyzed the leachate from the bottom ash, and as I said before, that failed the EP toxicity test. But the fly ash that was around the plant, sitting on the railings and sitting on the equipment, they analyzed that too. And they found 4,500 parts per million of lead in that ash. And workers in Detroit were moving that ash around using a shovel. And they had paper masks on to protect them. They had no idea what they were dealing with. Nobody bothered to tell them how toxic this material is, which not only has the lead and cadmium and the other toxic metals in, by design, you're trying to capture that stuff. And you've got them on particles of a size that will go deep down into your lungs, but also those fly ash particles are the site of dioxin synthesis. They are the particles on which the dioxin generated in incinerators is actually made. Risk analysis is a big, utter joke being played on the citizens in this country. It's a pseudo-scientific, don't waste time, it's a pseudo-scientific rationalization for a decision that has already been made. In other words, you make all your decisions, and the last hurdle that you've got to cross is to persuade the people in this town that this is not going to hurt them. That is the point, that you go to consultants and pay them an enormous amount of money to do a, quote, objective study. I don't know if any risk analysis has come back under those circumstances and said there was any risk from the incinerator, not from the people that have been hired by the promoters of these projects. It is a farce, and I spent the last 3 years with Tom Webster looking at the way that they get round and persuade us that we're not going to be unduly exposed. They don't consider all the pollutants, they don't consider synergistic effects, they don't usually consider upset conditions. Only relatively recently have they considered the food chains. When they consider the food chains, they don't consider all their assumptions are usually far from conservative. They don't consider the export of risks via food. They don't consider the cumulative impacts of all the incinerators proposed in a particular area, and they don't consider the risks from ash. Well, I think it's time that we looked into the trash can and saw what we were dealing with. And as we know, the classification will determine what you do with it. I'm going to classify it carefully. Discarded household materials. The 6 categories here. Reusables, objects which should never be thrown away anyway. You know, just because you put something outside your door doesn't mean that it's useless. You know, just because you put it out there and you don't want it in your house anymore. It might mean it's the wrong color, the wrong design. You want something else, you want some more space. Your mother's died, your son's died, or something you want to get rid of. You don't want it in the house anymore. It doesn't mean it wants to be crushed or covered with orange peel or burnt in an incinerator. That's ridiculous. So get the reusable objects. We've got to learn. Now, we have ways of doing it. Garage sales, yard sales, give it to a friend, sell it to a friend, take it to the thrift shop, Salvation Army, Goodwill Industries. But none of these things are comprehensive. We've got to do it in a comprehensive way, get those reusables back. Next, the recyclables. If you can't get the object, get the materials. You know all about recycling. Compostables. That's the key one. That's the one that's missing. Composting, to get the organics out of the landfill, all that organic waste. And then the one I love most is the avoidables. The avoidables are here. Isn't avoidable. This is a throwaway razor. Now, do you know, according to the EPA, we throw 2 billion of these away every year in the United States. 2 billion. This is a finite resource, this oil from which this plastic is made. Finite resource. Now, 2.5 years ago, I bought this, also made of plastic, but a little bit of metal in it. And I've found for 2.5 years, I've been able to keep this one going simply by recharging the blade every 2 or 3 weeks. Now, I knew I was stepping back to the 19th century. I knew I was being old-fashioned. I knew my friends would laugh at me if they ever found me doing this. And I knew one morning that I was going to be exhausted putting the blade in. Oh, how agony! Blade goes in, blades up, had to pick up the blade. That's exhausting. Put it in the little metal box. That's exhausting. Put it on the shelf. Oh, my day is ruined. Absolutely ruined. Only I could go for the modern convenience of this. how we can't do away with this modern convenience. Couldn't possibly. How did I ever get into this nonsense? How did it ever happen that a rational human being like me could ever buy one of these things instead of hanging on to this one? I remembered, there it was on television one night, there was this half-naked woman sitting on the hood of a Mercedes-Benz telling me that if I bought this, I would get her, the car, and a trip to Bermuda. Now, I did not... Now, all right, don't laugh, don't laugh. I didn't believe this for one moment. I didn't believe it for one moment, except my subconscious did. And the next time I was in the supermarket reaching for this, the waves started splashing in my subconscious, and over I got the plastic bag with the plastic throwaway thing. It's amazing. Maybe it's not a trash crisis after all. Maybe it's a sexual fantasy crisis. Maybe it's a sex crisis. We're just so frustrated in this country that we have to keep buying these things and throwing them away. It gives them some kind of sexual orgasm or something each time we go to the trash. Oh, it feels great. That's just one example. There are many, many other examples. And if I had another 2 hours, I'd go through some of the others. Anyway. And then we've got the toxics. There's only about 1% toxic material in the domestic waste stream, but it's a pain. It can cause a lot of problems. Of that 1%, 50% are in household batteries, the mercury in these batteries, the 1% mercury in the alkaline batteries, the nickel-cadmium rechargeable batteries, the lead in the car batteries. That's 50% of the toxics right there. Not very difficult to collect, not very difficult to store, and eventually, where are we going to put them? We know they can't go into landfills. We know they can't go into incinerators. There's only one rational place for them to go to, and that's back to the manufacturer. And we have to get whatever it takes with our citizens, with that 4x4 and our politicians, to tell them if the battery manufacturers have no willingness to take these toxic metals back after we finish with their batteries, then they have no right to put them in the first place. And it's as simple as that. We just can't keep turning a blind eye to these toxics, which they make a profit out of, but we're passing this problem on to future generations. And then finally we've got the rest. How should these be handled? How they're handled in some communities in Germany and more in communities in the United States is a 3-container system. There are other systems, but this is the one I particularly like. 1 container for all the compostables, the organic waste, a 2nd container for all the recyclables, maybe a special container for all the batteries, a bright red bottle, plastic bottle. Every time you use one of those household batteries, you put it into the bright red bottle, and when it's full, you put the lid back on, you put it into your container of the mixed recyclables. That will go to the separation plant, a very easy task now to pull the red bottle out. One movement of one arm takes out 300 or 400 batteries just like that. The compostables will go to a composting plant, the recyclables will go to a separation, an upgrading plant, the dry residue will go to a landfill, and that's going to cost you money. And the most important thing is that we do upgrade those landfills, we do make those landfills very expensive, and that in itself will simply drive these other rational solutions. So the whole scheme looks something like this, where the reusable objects, I would like to see those go to a reuse and repair center. Gives you an opportunity to employ people, to train people. Maybe our senior citizens with the skills for repairing refrigerated stoves and furniture can actually be training people to do that. And another advantage of this too is that the other half of the toxics in the waste stream are things like paints, paint thinners, paint strippers. Why don't we use those up? If they're safe enough to use, then they're safe enough to use up. If the individual can't use them up, then maybe we can use them in the reuse and repair center for the purpose they were intended. Paint the furniture, strip the furniture, clean the objects and so on. Use that material up. And maybe have a waste exchange there too, a whole rows of cans of paint you can help yourself to, and so on. There are problems with that, but at least there are problems worth tackling. The recyclables to a separation plant. There's a model almost for this very close to here in which county? Fillmore County. It's very low tech. It's far too cheap for many of our decision makers. They don't want cheap things. They want expensive things. But if you want to save money and keep it simple, then Fillmore County is a place to start. It hasn't gone as far as I would like. I would like to see a separate container used for the compostables. They're pulling the organics out of the rest. And they don't have the reuse and repair center there, but they could. And But what they do have is that they do have separation lines for the rest. So instead of committing the rest directly to a landfill, they pull stuff out of that too. As I say, if you keep the landfill expensive, you're going to drive these things together. And this, ladies and gentlemen, is really what we mean by integrated waste management. Because what you've done with an expensive landfill is you've put the taxpayers and the environmentalists on the same side. Because if you're a taxpayer, you're going to save, the community is going to save money every time it diverts anything from the landfill. And if you're an environmentalist, you're going to be delighted every time you recycle, reuse, or compost something. So you've put people on the same thing. You've got an integrated system because your components are compatible. And you make the least desirable the most expensive. With incineration, you make the least desirable the most expensive but unavoidable, which is not exactly a good formula. There are other things that I would suggest here which you might not think of instinctively. I suggest that these containers could be provided to everybody for free. And that's a big bill. But why not go to all the corporations in town and say, do you support recycling? Yes. Let's have their name on the container saying we support recycling in Clacton or wherever it is. And their name gets out on the streets every week as being a very good corporate citizen supporting nice, good things. So that's one thing. Another thing to do is to play around with the economics. And I was delighted to see that this is actually happening in Fillmore County. If you deliver mixed trash to Fillmore County, you pay $40 a ton. If you deliver mixed recyclables, it costs you nothing. So it's worth the hauler's while to keep getting the recyclables up there. And finally, if you deliver separated recyclables, they pay you. So there's an incentive for separating. Now in New Jersey, they have one community has a nice little scheme. You have to buy so many coupons at the beginning of the year. And each time you use a trash bag, you use up one coupon, $2 or $3 worth. But each time you put out the recycling container, that's nothing. And each time you put a settee out, that costs about 6 coupons. Right? So people are getting very imaginative about what to do with old settees. Much more imaginative than they were before. So you can use these economic incentives to drive the whole thing. Well, here's the 3-container system in Germany, same color in the kitchen, the brown for the compostables, the gray for the rest, and the green for the recyclables. Here's the typical household organics. Here's the rest going into that, same color code. Here are just different collection vehicles around the country. This is Davis, California, where they design their own trucks. This is El Cerrito, California, a very nice system with drop-off boxes, which you then load onto your truck. This is North Freedom, Wisconsin, where they put all the recyclables into a regular compact truck. This is California, 3-container truck, very simple to use, very effective. This is an amazing device here, again in Davis, California, for collecting yard waste. Very interesting. And the size of these things can vary from, this is the small shed in Rodman, California, which cost $9,000. Low tech, look, you can't get much lower tech than this. He's preparing the containers. Isn't that lovely? And this is 3 acres under one roof. It cost $10 million. This is the biggest in the United States for separating mixed recyclables, conveyor belts and chutes and drop-offs and spinners and you name it. They're all designed to capture the recyclables, incidentally, from the commercial waste and the yard debris and things like that. This is back to North Freedom. They use senior citizens. They volunteer to do this. They can earn up to $100 a day just collecting the coupons on the cans. Low-tech equipment, balers, crushers. This is Stevenson, Washington, where this separation facility was designed by a young man who hadn't quite got his engineering degree, Brett Norland. He got a $400,000 grant from the state. He built the whole thing from recycled materials. He uses a carousel approach for separating waste, dropping into different chutes dropping down underneath. Very elegant system indeed, and getting a 70% volume reduction in the trash. This is Camden, New Jersey, designed by Peter Carter, a former nuclear engineer, and here he'll take a whole truckload of bottles, cans, and upgrade them. Here's a truckload of Cummings bottles and cans, and that will be upgraded into green, white, and brown glass cullet, aluminum cans, and tin cans, and there's no problem with marking that material. The business about marketing recyclables is you need quantity, quality, and regularity, and we need some leadership. Obviously, we will begin to exhaust markets as we get more and more of the communities doing this. But that's up to leadership. If you can see that coming down the line, the President of the United States downwards should be organizing those markets to receive it. Here's a separation of the paper and the corrugated on conveyor belts. We saw some hand separation there. This is over in the separating the commercial waste, the building debris, yard waste. This is after a curbside collection program. This is a bit like the Fillmore County operation. This would be the section where they're handling mixed waste. This is just outside the Black Forest, handling about 100 tons a day of mixed recyclables and outbound conveyor belts. And these different people are sorting out newspapers, corrugated cardboard, plastics, glass, metals, and so on. A little bit of technology to help in the separation. Some of it rather elegant. I rather like this one. Magnets, of course, useful. And this is genuine resource recovery now. This is the recycling of mixed post-consumer plastics. The Belgian system, the ET1 system, you can take detergent bottles, etc., 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 and make them into fence posts and other things. Advantage, don't need wood preservatives for those plastic lumber. Here is commercial waste. Now, most of the focus is on domestic waste, but the commercial waste is much easier to handle because it's more homogeneous, mainly office paper and corrugated cardboard from supermarkets. And if you make an effort to keep the food waste from the restaurant separately, then it's not a big deal to separate this material. Here they're separating office paper in San Francisco. These containers are from offices, and they upgrade the paper. They separate the white and colored ledger, the computer paper, and so on. That can be done. I think that's a place where prison labor might be very useful. Here is a huge facility handling commercial waste, 1,000 tons a day in Burbank, California. They've gone one stage further. They take the mixed paper division and pulp it on site. So what they deliver to the paper industry is a great pulp, which gives them a more secure position in a very fluctuating marketplace for mixed paper. That was a $3 million investment, a very courageous step, I think, for this particular company. Whilst we're doing this, we're going into the more grander separation plants. We mustn't forget the scavengers. We've got to keep these small guys in business. And I was very impressed with Fillmore County that they've set the prices that they pay for separated recyclables less than the other operators in town, not to outcompete with them, because it's unfair for the municipality with their bottomless pit, as it were, to compete with private enterprise. So you have a buyback center. You make sure that you always buy back. This is in Berkeley, California. You drive up to scales, you put it on the scales are connected to a computer. By the time you go to the office here, the check has been written out by the computer. There is no cash on the premises. A very effective thing. They not have the buyback, but also the drop-off center here. This is Urban Ore in Berkeley, California. After the drop-off and the buyback, you have the reuse center. Junk, right? Huge flea market, grossing $17,000 a month selling that junk, from everybody to Steven Spielberg to the boat people. Amazing. And then just down the road, 3 blocks down the road, he has another place for building materials. Doors, windows, here we go, doors, windows. I've never seen so many doors in my life. Toilet bowls, you name it. And that is grossing $25,000 a month. The builders now take to him and sell to him, and then he sells it back to them when they're repairing older houses. Some of those things are very valuable. The odd-shaped windows and things are very valuable. $25,000 a month being grossed there and employing people, exciting people. One of the top graduates from Berkeley worked there for 2 or 3 years. And here over in Portage, Michigan, Jay Eaton, a wonderful recycling place, separating everything, etc. But in addition, he has a repair shop. And Jay is repairing everything. He says that, you know, if you stand here long enough, he says anything you want will come to you. Just make a wish, it will come to you. You might have to wait a long time. It's unbelievable what people throw away. I mean, look at these. Those cost about $80 each, those things there, air regulators, these power tools. Look at this. Incredible. He repairs them, he paints them up. You see the old shovels, he's got the rust off and paints them up. And amazing. Absolutely amazing. I was really impressed. He's only spent $200 or $300 on this whole outfit. Nearly everything that's there has come through the waste stream to his recycling center. And as I said before, this is a way of using up some of your toxics Instead of sending them off to chemical waste management, use up these paints and these things. Use them up. Here he's used them up. He's painted that shovel. See that? Now, this is in Wellesley, Massachusetts, which has the most... Let me break off here. I got to tell you about Wellesley. I got to tell you about Wellesley. This is one dump that no one's going to get rid of. This dump is made around an old defunct incinerator, the best kind of incinerator. And they have a long row of beautifully displayed drop-off containers. And they have that Goodwill Industries truck. They have a place down the basement of the incinerator to leave off your waste oil, your tires, your batteries. Round the back you can leave off your grass clippings and leaf clippings, etc. and help yourself to compost made from that last year. And then there's a take it or leave it section. You can put down your old appliances and it can help yourself to other people's old appliances and bric-a-brac. And then the coup de grace is, as you're going out, there is this bookshelf where you can leave books, help yourself to books, and even order books. Keep an eye open for George Orwell. Put your phone number down. They're going to ring you up when George comes through. Now, the result is that parents punish their kids by not taking to the dump on Saturday mornings. And the politicians, like Elliot Riddison, when he was campaigning for office, he went there on a Saturday morning. He knew everybody's going to be there. Big community center. So you start by recovering material resources. You end up by recovering your community and some human resources if you do it the right way. This is all the different ways that you can compost in your backyard with the different commercial and household composting systems. Very simple ones, more complicated ones. This is Seattle. This is the Tilth Association. They have this regular demonstration. We've got all these on videotapes if you want to get them. This is the Earthgrow system in Lebanon, the Windrow system. And here's the Scarab, which if you want to see one in action, go down to Fillmore County. It's very good. You go down the whole Windrow with one swoop. One swoop at the Windrow with this. And people are worried about rats and things getting into the food waste. Don't worry about it. They get composted too. Every day, little bits of rat. Okay, and then in here, rats. Okay, over here's an internal Windrow system, the trough method of composting. Inside a shed, 6 feet wide, troughs, 6 feet high, machine that runs down on rails on the top, shifts the material 10 feet a day. It's 180 feet long. By the time 18 days later, the material that went in one end is ready at the other end. That's the trough system, a very elegant system developed in Japan and now being used in this country by a number of companies. And air is blown through the bottom. You can control the temperature by the supply of air, which is critical. You can clean the air that comes off with a variety of filters. And here we are in Heidelberg, West Germany, where they have composting now, household organic waste collected from a community of over 100,000, and the composting here is done in huge in-vessel systems. Here's the in-vessel, huge towers over here. You've got giant paddles stirring the organic waste. You've got air being blown through the top and sucked out of down the bottom, sucked out of here's the big paddle wheel. Here's the paddle wheel going around. Now there's big blades which are turning all this stuff. So obviously from what we've seen, you've got to turn it some way. You either use a scarab or you use one of those little tractors or you use big paddles. And here we see the stuff coming out of the bottom. I grab a handful of it and smell it and decide that it smells okay. And it's not bad stuff. I mean, you've converted many problems into a product, which you can use for a variety of reasons. I don't think we should take lightly the input to such a facility. Don't be conned into thinking that you can compost mixed waste. You cannot. But you can compost separated organic waste. Keep out the toxics, keep out the other objects. This is a Bowden filter. It's an earth filter, so the air goes through this filter, and here's the compost coming out of the system. So this is a very grand affair in Heidelberg. And after it's been in that machine for 2 or 3 days, it's put outside for curing out here. The criticism of this is, well, you can't make take a big chunk out of the waste stream. One of the weaknesses of the analysis on recycling is people don't make a distinction between volume, meaning space savings, and weight savings. In fact, there's a much greater space saving when you're recycling than a weight saving. So if you just concentrate on how many tons you recycle, it may not look too impressive. But you look at the space that you've saved in the landfill, it can look very impressive indeed. So in North Stonington, a 65% volume reduction, space reduction, 2 years after a mandatory recycling program. Rodman, New York, a 71% volume reduction, largely because they're pulling out the plastics, which are a huge volume item, after just 4 months. Incidentally, there were two things they were told there. They were told the American people, it was going to take Americans 3 generations to separate their trash. 3 generations. They did it in 4 months. It amazes me that we think that the American people are so stupid, they're so lazy. And now I've had politicians say to me, Dr. Connett, we know that you would recycle. And quite frankly, I recycle. You should see my basement. You should see my basement. I separate everything. But the slobs that voted me into office, they would never, 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 never recycle. There are a bunch of animals out there that voted for me. And you know, there's Michael Frisch is in the audience here from the Center of Biology and Natural Systems, and they did a very interesting thing in Buffalo. They asked the people in the rich, the poor, the middle income areas, they said, would you recycle? And about 80%, it didn't make any difference whether we're talking to poor, rich, or middle income people, about 80% said yes. And then they said, would your neighbor recycle? Only 25% said yeah. Yeah. Everybody's a slob and animal but me. Watch out, you know, they're awful, awful people. And another thing, you talk about separation. How does the average person treat their washing from a washing machine? Well, of course you pick it up, all of it, take it upstairs and dump the whole lot on the bedroom floor and say, husband, wife, kids, help yourself. Shirts, towels, socks, handkerchief, pajamas, all mixed together, right? That's the way we do it. Because we don't like to separate anything, right? Oh, Mr. Westinghouse, please invent a machine that will separate my washing for me, because it's ruining my day. Unbelievable. No, I have been into houses where they put the shirts in one drawer, and the socks in another, and towels in another, and washing up, cups and saucers, plates, knives, forks and spoons, all in the same big box. And when you go to set the table, go in. It's crazy. In East Hampton, Long Island, and talk to Michael, he's got the report with him. 100 households, they've got an 85% reduction by weight with this simple approach. 2 containers for recyclables, 1 for compostables, 1 for the rest. They didn't even cycle plastics. Now, of course, the response from industry is, well, those people are committed. They wanted this program to work. And I say precisely, if you can get 85% when you've got commitment, shouldn't then our task be to get commitment? And don't tell me you can't get the American public to recycle. Don't be ridiculous. If I have Bill Cosby and I have you all recycling, the whole of the United States recycling in a few months flat. Don't forget, we are the recipients, and I've went through it already. My goodness, where are my razors? I've been through it already. We have the most sophisticated selling machinery in the whole world. They can sell us anything. Look at the food we eat, the stuff that we drink, the stuff we watch on television. They can sell us anything, and they couldn't sell us protecting our planet, protecting our future, protecting our children with a few minutes effort each day. Then, my goodness, those PR people are not as good as I thought.
The trash man cometh and he wants to make you rich.
If your name is picked at random from the list of Rockford residents, and Todd and Jim can paw through your garbage without finding any aluminum cans or newspapers, you win $1,000.
Oh no, I think I have found, 2 aluminum cans.
Okay,
that's too bad. That's you don't win money with aluminum cans that way.
Why is Rockford playing a game with your garbage?
That's it.
Recycling is something that basically everybody should do, and everybody knows that they should do it. You put up that $1 reward, and it's like, now it's fun, you know? Before it was a little bit of a chore. Now that you can win money, this is fun. Whose name did we pick for Cash for Trash this week, Mr. Milliken?
One Robert McVinney. About 6 o'clock the other morning, Todd and I were in his neighborhood in front of his house at 6 o'clock in the a.m. We picked up his trash, and we're here to give him a check for $2,000.
Since the Cash for Trash game started, the recycling effort in Rockford has quadrupled. The program has been written up in the New York Times and taped by Japanese television, and everyone agrees a lot of the credit for the success of the game is due to the flashy trash man himself.
Well, let's summarize. It's clear that whichever way we go now, we're going to have problems in solving our trash crisis. We can't continue with raw waste landfilling. I think everybody agrees with that. Incineration poses many problems. Separation and recycling also poses a number of problems, particularly with marketing. But I think the art of decision-making is to choose that set of problems which takes us in the right direction. And for my money, source separation takes us in the right direction. Because trash is not a high-tech problem, it's a low-tech problem. There are no magic machines to solve the trash crisis. Waste begins at the manufacturing level and it continues at the consumer level. We make waste by mixing. And if you're going to unmake trash, solve the trash crisis, then the simplest starting point is to keep that material separate. Source separation, either in the office or in the household level. And with separation, many important things can occur. Number one, we can get marketable recyclables because they won't be contaminated with other materials. Secondly, we can get usable compost because the compost will not contain the toxics. And thirdly, related to that, with source separation, we have our best shot of getting the toxics out of the waste stream. And fourthly, with separation, we get education. Another way of putting it is if you have incinerators, then you convert 3 tons of trash into 1 ton of ash. With source separation and recycling, we can convert 3 tons of trash into 1 ton of recyclables, 1 ton of compostables, and 1 ton of education. The education is both simple and profound. The simple message is you cannot run a throwaway society on a finite planet. In practical terms, that is going to echo up the decision-making line to the manufacturer in this form. If you can't recycle it, don't make it. If we have our people putting the effort into separation, into recyclables, compostables, and the rest, the focus of attention will ultimately focus on the rest. Why are we making this stuff if at the end of the day we have to throw it away? Now, another important point about source separation is that we're going to have landfills whichever way we go. With incineration or with intensive recycling, we still need a landfill, either a landfill for the ash after incineration or a landfill for the residue after recycling and composting. Now, the traditional approach to siting a landfill is to try to persuade people that nothing is going to come out, that we can control what leaks out of the landfill. Nobody believes that anymore, including the US EPA. Nobody believes that you can actually build a leak-proof landfill. So a more practical approach, I believe, is to control what goes in. It's with source separation that we have our best chance of controlling what goes into a landfill. To make source separation work, we've got to make it convenient. I can't think of a more convenient way of handling trash or the recyclables, etc., than to put out the container for the recyclables and the compostables on the same day that you put your trash out at curbside. Second, we've got to make it urgent. We've got to tell people that there's an urgency here. We are all part of this problem. We could all be part of the solution if we were prepared to put a few minutes into it. And what's exciting about that urgency is that this is one major environmental problem that we could do something about. Do it for your future. Do it for your children. I think we can make it urgent. We can communicate that urgency. And then we've got to make it mandatory, source separation. It's no point in telling people that something is urgent and then say you can do it if you want to. That's a mixed signal. If it's urgent, then we should make it mandatory. But that doesn't mean that we make it very painful and punitive. I think at the same time we've got to make it fun. I think that's where the trash man comes in. I think it's where other folks could come in, like Captain Garbage. The only obstacle to what we're talking about, source separation, reuse, recycling, composting, toxic removal, and long-term education for waste reduction, the only obstacle that I can see is a lack of political will. That's where we, the people, come in. We've got to give our politicians the will to give us the leadership to lay on these systems so that we can be part of the solution and not part of the problem. This is the only way to go if the future really matters.